So maybe just a few minutes ago, you heard me babble on and on and on about TLC and what TLC is and how TLC is different than traditional column chromatography. All right, so we need to go on and we need to talk more aspects about the TLC. And the first thing that I want to say is that TLC is used for multiple reasons, all right? So one of those reasons is just to figure out the number of components in a mixture, right? Because remember, TLC traditionally does not do quantitative work. It's qualitative only. So someone could go into the laboratory and they could put a mixture or a sample onto the TLC plate and allow that plate to develop, and they can actually get an idea of how complicated this mixture is. So if I run the plate and I see one spot on the plate, then that probably means, not guaranteed, but it could mean that I've got only one component in the sample that was provided. If I see 3 spots on the TLC plate, that probably means there's 3 components in the sample that I'm to work with. TLC can also identify a substance. So if I do see basically a spot on the TLC plate, then how do I know what that is? Well, if I have a general idea, I can run a standard against that sample. And if the standard moves up the plate so far and my sample moves up the plate the same distance, then all of a sudden I could maybe reason out that that spot is the standard that I ran if they move up the same distance, right? The same thing happens in chromatography. The effectiveness of a purification. So let's say that I'm in the laboratory and I'm working with something, and let's say that that product is given to me and they want to make sure that that product is pure. So one of the things that I can do is run it on a TLC plate because it is chromatography and it separates things and components from each other. So if it's pure, I should only see one spot on the TLC plate. And if it's pure, then I can give a check mark off of that because of it. Well, I would do TLC because it's cheap and it's fast and it's much quicker versus running it on a piece of equipment. If I have any questions about that later on, then I can run that on a piece of equipment. But just as a dipstick check, TLC plate's a great way to go. The appropriate conditions for a column is another reason that maybe I would use TLC. So the appropriate conditions for a column, what does that mean? Well, that basically is relating it to the chromatography world. So I can get TLC plates made out of different stationary phases, just like I can order columns made out of different stationary phases. And then I can change my mobile phase depending on what we do. So literally what I can do in a laboratory is to go in and set up a series of beakers, one side by side by side by side, and I can put a TLC plate into each one of them, right? And in this TLC plate, they can all be different. So plate number 1 and plate number 2 and plate number 3 and plate number 4, and they have different stationary phases on them. Well, I can then put my mobile phase in, and I can allow the TLC plate to develop, and then I can start to see my spots. So are the spots okay? Do they look okay? Is it something that I would expect to happen? If not, then I can keep changing the TLC plates to find a stationary phase that works the best. Well, I can change the stationary phase in this manner, or I can change the mobile phase in that manner as well. So I can take the same stationary phase or my same TLC plate, put them side by side in a series of beakers, and I can just change up the mobile phase in the beaker. That's all I've got to do. So maybe in the first one, I do a methanol water mix, and in the second one, I'll do an acetonitrile and water mix, and in the third one, I might just do full water, and in the fourth one, I might do an alcohol, who knows? But I can have the easiness, if that's really a word, of being able to develop, or convenience, I guess, of being able to develop multiple plates at the same time. And then I can pick out the right combination. So that way it saves me a little bit of time from going to the actual instrument and changing all of the settings on the instrument and only doing one run at one time. So appropriate conditions for a column, that's what we mean when we say that. The progress of a reaction. So very often, if a company is making some type of product, throughout the production line, they could pull samples off of that production. And those samples can be provided to me, and I can run them on a TLC. And I can kind of identify the step at which maybe I'm starting to get a pure compound. Or I can identify the step where byproducts are beginning to form and contamination maybe is coming into the picture as far as the synthesis route goes. So the progress of a reaction, very, very important, and I can use TLC to help identify that. And then finally, the column chromatography effectiveness. This is listed separately just because this is the overall picture of chromatography, whereas this one is in reference to just the column only. So this is the stationary phase and mobile phase of the column, and then this is the overall column chromatography effectiveness. How well do they separate from each other? Is my resolution going to be appropriate? Is there any problems associated, or are there any problems associated with the mobile phase and the stationary phase and the interactions that happen in between? So that's what we mean by column chromatography effectiveness. All right, so over here to the side, what you're going to see is a TLC plate, and this is a picture of a plate, and there's basically different samples that have been spotted onto the plate. And again, we'll talk a little bit about this in a couple of slides later down the road when we talk about the plate itself. But this is where your samples would go, okay? So the plate goes down into the mobile phase, and the plate will begin to suck the mobile phase up the plate. And as the mobile phase gets sucked up the plate, that mobile phase is going to grab onto your components in your sample, and it's going to start to move them. They begin to migrate with the mobile phase. So the migration rate will be different depending on how it interacts with the stationary phase and the mobile phase itself. So if you look at the first lane, this first lane really has one spot, and that one spot maybe would let me realize that there's only one component in that sample. If I look at the G lane, the second one over, I see the spot, but it's more up to about the middle of the plate here. Well, I can kind of reasonably conclude that this spot or sample or component is not the same as the T lane, the very first lane, right? If it was the same, then those spots would be about the same distance from the bottom. But this one's moved much further ahead, which means that it's a different compound because it's behaving the stationary phase and the mobile phase differently than the first lane. With the EE, this one, it looks like there's three components in the sample that I was provided, because I see the spot down here at the bottom, and then I see a larger spot here in the middle, and then I see another spot up here at the top that has separated out. So each spot represents a different component, right? And I can maybe conclude that this sample has three components in it at least. I'm going to start to question this big blobby spot here, because it almost looks like this spot maybe is trying to separate on itself again. I see that kind of taper up at the top, and I see this round kind of teardrop here at the bottom. I'm going to say, just for the purpose of this video, that this is just one component. But if I was doing this in a lab, I would scratch my head and I would be, okay, well, we need to take more consideration on this spot here, because that looks like it could be made up of more than one thing, and it's trying to separate out and give me two smaller spots instead of one larger one. If I take a look then at the next lane, it's also labeled as T. And that is basically the same as the first. And what they're doing is that they're showing you that those spots have moved up the plate about the same distance. They're a little bit different shaped. One's a little bit further out than the other, but overall they're pretty close. If I look at the P lane, there is no spot here that's been identified at all. That's just completely blank. So there's no component in that maybe, who knows, but there's a reason that something's not been picked up. And then finally, in the last lane of EE, that's the same as this EE. And if you compare and contrast, you see the bottom spot about the same. You see that the B spot is about the same shape as well. And then you see that the C spot is about the same distance and about the same shape as well. So that would lead me to believe that sure enough, this thing does have 3 components at least, and maybe more, depending on what happens to this B blob, right? Okay, so down here at the bottom is just an overall picture of what's going on in thin layer chromatography. So we take a plate that has sample on it down here at the bottom, and we take the plate and we put it into a beaker or a chamber that has mobile phase in it, and that mobile phase is down here at the bottom in blue. The plate is going to start to suck up the mobile phase, and that's what you're seeing here in the third picture or diagram. And as it sucks up the mobile phase, what you're seeing is that your sample is beginning to move and beginning to separate. So that's why you see a blue spot and a red spot now. Over time, tick tock, tick tock, tick tock, that plate will continue to suck up mobile phase, and those spots will continue to migrate and continue to move. And then tick tock, almost to the very top of the plate, we then take the plate out and we allow it to dry and evaporate off, and those spots are going to be on our TLC plate for identification. So again, it's just a quick identification process. That's all there is to TLC. We develop what we call a plate into a chamber, and those spots represent the number of components that might be in my mixture that's provided to me in a laboratory.